Welcome to another lecture. In this lecture, we are going to talk about capacitors and inductors. So here you have an actual image of a capacitor, and here you have an actual image of an inductor. Here are the electrical symbols for capacitors. So both of them are used, and here's the electrical symbol for inductor. So what is a capacitor or an inductor? So capacitor is just simply two pieces of metal sheets brought very close to each other. So when you actually apply a voltage across the capacitor, what happens is opposite charges accumulate on the metal sheets, and there is an electric field and attraction between the two pieces of metal sheets, and this actually stores energy. Okay, so strictly speaking, a capacitor is just two pieces of metal sheets brought close to one another. Okay, so that's what a capacitor is. What about an inductor? Okay, an inductor is basically just a coil of wire and nothing else. So you might be thinking, why is it so different from just a piece of straight wire? Okay, so the difference is because you have a coil here, this acts like a magnet and can store magnetic energy. Just like capacitors store electrical energy, inductors store magnetic energy. And when in a changing magnetic field or the electric field is changing, there is an effect that's described by Faraday's law. And this is what makes it a different electrical component than just a simple wire. Okay, and it has profound effects. Okay, so this is what our topic of today's discussion is, but I want to take a detour into something else, how a circuit, how they are exactly used in circuits. But before that, I want to talk about open circuits and short circuits. On the screen, you can see two different circuits. The one on the left is an open circuit and the one on the right is a short circuit. So we have already discussed open circuits and short circuits, and by now you should know that if a circuit is open, that means not connected at all, there is no current flow. So there will be 0 amperes of current on the left. Okay. And on the right, we have a short circuit, and a short circuit is basically just a piece of wire. We can also say that the resistance here is 0, and in the open circuit case, we can also say that the resistance here is infinite. The resistance is so much, there is no current at all. And here, on the short circuit case, there is no resistance at all. As a consequence, what happens is that on the right, you will have a current flow. Because this is just a piece of wire and this is a complex circuit connected everywhere. So you will have a 10 volt divided by 1 kilo ohm or 10 milliamperes of current. Also, one other fact, what about the voltage? So you have ground here on the right, so this will definitely be 0 volt. This node will be 0 volt, and this node will also be 0 volt. Because this is a piece of wire and there is no resistance at all, there will be no voltage drop. Okay, and this will be 10 volt, but that is not important at all here. We want to focus on our short circuit area. Okay, so there is no voltage drop, but there is a current flow. On the open circuit case, this is exactly opposite. We have no current at all, but there can be a voltage difference here. And what is that voltage difference? Well, let's see. We have 0 volt here, and on the left we have 10 volt here because of the voltage source. And what's the voltage of this location? Well, this node is actually also 10 volt. Why? Because there is no current, you can use Ohm's law on this resistor to figure out that since there is no current, that means there is no voltage difference between these two endpoints. So there is no difference, that means that's exactly the same voltage will appear here. Okay, so you have actually a 10 volt voltage difference here. In actuality, you can Okay, so we have established that there is no current in open circuit case, but there is a voltage difference, right? And I think it's better if we see this thing in a different light. You can say that there is a 10-volt voltage source here, which is kind of opposing this actual voltage source, right? So this is why actually open circuit connections don't flow. There is no current flow through the open circuits, because there is kind of the open circuit acts like a opposing voltage source. Okay, so this is the thing. The main thing here is that you can have a voltage here. And why am I talking about open circuits and short circuits when I'm discussing capacitors and inductors? Well, that's because capacitors, if you remember, are just two pieces of metals. So if you see from this direction, you will see something like this, and this is why the electrical symbol is like that. There is a gap here. There is no electrical connection between these two metal sheets. So what happens is the capacitor is almost like an open circuit. So this acts kind of like an open circuit, and in fact, if you create a circuit just like that, so you have 10 volt 1 kilo ohm resistor and a capacitor instead of an open circuit, and if you like construct this circuit in real life and maybe come back after a day, you will see that in fact this has have now 10 volts of voltage across two plates, and there is no current. So you will see the exact same thing. Okay, but the slight difference is that it eventually becomes, this is very important, this eventually becomes an open circuit. So it takes some time to open the circuit. Okay, so a capacitor eventually becomes an open circuit, but it takes time. So you have to come back a day later. After you make the circuit, you have to come back a day later. In reality, this is like only takes like a few milliseconds, but I'm just exaggerating things. Okay, but the fact is, capacitors can store voltage just like open circuits does, and it takes some time to charge the capacitor. Okay, so in open circuit case, it's just an instant. In an instant you have 10 volt here. Okay, so this 10 volt doesn't take any time at all, whereas if you replace with that open circuit with a capacitor, it takes a bit of time. So maybe it takes a few milliseconds or something, or a few seconds even sometimes. Okay, so that's the difference. But a capacitor is kind of a glorified open circuit. Okay, and on the other hand you have inductors. Inductors, if you remember, a piece of wire, basically that's also a piece of wire, but that's a coil of wire, right? But nonetheless, this is a piece of wire. So this also kind of eventually becomes a short circuit. Okay, so if you make a circuit with an inductor, 10 volt 1 kilo ohm. So if I use an inductor instead of directly shorting the circuit, and doesn't matter what value it is, maybe if you make the circuit today and maybe come back a day later, you will see that in fact there is a 10 milliampere current and there is 0 volt across this circuit. Okay, across this inductor. Okay, whatever the value is, doesn't matter right now. So there will be no voltage difference, but there will be a current through this, and this is like exactly as if this is a short circuit. So this is what capacitors and inductors do. They eventually become open circuit, or inductors become short circuit. But the thing is, it takes some time to open them. Okay, so the capacitors actually need time to build up the charge and voltage up to 10 volt, because capacitors, the reason why we used a metal plate is that when electrons are coming in, it takes time to build up the charge here. So this eventually will become positive voltage, and this will become negative voltage. But since the plate is so large, it takes some time for the electrons to accumulate and make the voltage 10 volts, let's say 10 volt. Okay, so it takes some time. Similarly, for inductors, this takes some time to build up to the 10 milliamperes of current. So there is a 10 milliampere of current in this circuit, but it takes some time from going to 0 milliamperes of current to 10 milliamperes of milliamperes of current. It takes some time. This is because the magnetic field of these coils actually opposes the current's increase. So the magnetic field doesn't want the current to increase. So as a result, it takes some time for the current to build up to that 10 milliamperes. Okay, so basically capacitors and inductors eventually becomes open circuits and short circuits respectively, but it takes some time. In fact, if you draw a graph, this is what we are interested, and this is what's called the transient analysis. We will go into details later, but let me give you the idea here. So if we plotted the time here, instead of okay, I have written here 10 volts before, but that's what it eventually becomes. But if I plotted the capacitance, the voltage across the capacitor with respect to time, so it will look something like this. It will start from 0 volt, because at the start of the circuit it is 0 volt. Then it builds up to 10 volts, right? So it gradually creeps up to 10 volt. Okay, gradually creeps up to 10 volt. And for the case of inductors, that's what happens with the current. So this is okay, inductor is represented with L. This is controversial, but it's usually denoted with L because we use I for current. And if we plotted the current, what happens is that let's say this is 10 milliamperes. So it takes some time for the current to grow up to that 10 milliamperes of current. Okay, so it creeps up to that 10 milliamperes of current, and we will see that in details later. But this is the main idea. In fact, this curve is actually basically just exponential in nature, and that's what we are going to do.